Hello, everybody. I thought I'd take a minute and make a quick video today that went over your homework 63. That is your chapter 5 polynomial review. All right, you don't have to watch this whole video. You can feel free to skip ahead just to any problems that you had trouble on, but hopefully we can get through all of those problems on that review today. All right, let's go ahead and look at problem number 1. So problem number 1 says factor. Okay, we always want to look to see if there's any greatest common factor that we could take out. And in this one, we could actually take an x out of all of these. See how they all have an x variable? And they can also all be divided by 2. All right, so I'm going to divide each of these by 2x. All right, so I'm going to factor out my 2x. 2 divided by 2 is just 1 x cubed, and we're going to subtract one of those x's. Now it's an x squared. Negative 8 divided by 2 should give you a negative 4x, and negative 10 divided by 2 should give us a negative 5. All right, now we're not done yet because we want to see if we can factor this right here. All right, so when I factor, I draw my x, we multiply to the top, we add to the bottom. All right, in this case, our a value is 1, so we want to multiply to 1 times negative 5, which is just negative 5. And we want to add to negative 4, our b value. All right, so I always make a little t-chart. So I want to multiply to 5, so that would be 1 and 5. That's it. Those are your only factors. So we know it has to be some combination if this one is factorable of 1 and 5. All right, notice we want to add to a negative 4, so I'm actually going to make this a negative 5 because negative 5 plus 1 is negative 4. All right, so now I can write my final answer here. This would be 2x times x plus 1, x minus 5. All right, and now this is completely factored for our first problem. Let's go ahead and move right along to number 2. Okay, number 2, you'll notice we only have 2 terms. That's what we call a binomial. All right, whenever you have a binomial, we always look to see if this is subtraction. If it is, chances are we have difference of squares. So what you can do is you can take the square root of the first term and the square root of the second term. Square root of y to the 4th power is going to be y squared, because y squared times y squared is y to the 4th. The square root of 16 is 4, because 4 times 4 is 16. All right, now you'll notice that the middle term is canceled out. There is no middle term, no b value, right? So that means I make one of these addition and one subtraction, because if I were to multiply this out, this would be y to the 4th plus 4y squared minus 4y squared minus 16. Whoops. Okay. And notice that these two cancel each other out. So this would be my answer right here. Moving right along onto the third problem. Oh, this one we have a polynomial because it has 4 terms. All right. So what we do on these ones is we're going to factor by grouping. All right. So I almost split it in half here. All right, and now I'm going to look for a GCF, or a greatest common factor, in these first 2 terms. So just these 2 right here. All right, and I can see, well, they both have 2 x's, right? Even though this has 3 x's, well, the greatest common one that they share would just be these 2. So I'm going to factor out 2 x's, and notice we can divide both of these by 6 as well. All right, so I'm going to divide them by 6 x squared. All right, so let's go ahead and do that. 6x squared, 6x squared. 6 divided by 6 would just be 1, and 3 x's minus those 2 x's, we're left with just x to the first power, or we could really just say x plus, well, these x squareds cancel, and 12 divided by 6 is 2. All right, and now we're going to look for a GCF in these second two terms. Okay, so notice in each of these, I could divide by 12. We can't divide by x because this 24 does not have an x. So I think our GCF is just 12 in this one. So factor out your 12. So this would just be 1x, or we could just say x. And 24 divided by 12 should give us 2. Now, if we did this correctly, these two in parentheses should match, which they do. And we want to combine these two outside ones. So this would be 6x squared plus 12. And then we just copy down that x plus 2. And that would be how we would factor by grouping on this one here. All right, on to number 4. Number 4, we have x cubed plus 125. So notice it has two terms. So we're thinking, oh, it's probably a binomial, which would mean difference of squares. However, one problem with our difference of squares here, this is addition. Okay, so we actually do not have difference of squares here. Instead, we can use this formula to kind of help us out. A cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. All right, now let's look at what we mean here. All right, so in this one, here is going to be my a term, and here is going to be my b term. All right, so notice we want a cubed and b cubed. Well, we already have x cubed, so that was easy. But now we want b cubed. And you see how b is 125. Well, it turns out 125 is 5 cubed. So I'm going to rewrite this as plus 5 cubed. Okay, so this would be how we would factor it. So now let's factor it. So we want a, which we said is just that x value, right? Plus your b value, which in this case is 5. A squared, well, a squared would be x squared, because this is our a and this is our b, minus a times b, so that would be 5x. All right, and then plus b squared, and b is 5, so 5 squared would be 5 times 5, which would be 25. And this would be our factored form right here. So let's just see if this factors any further. We would want to multiply to 25 and add to -5. Okay, so factors of 25, we have 1 times 25, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 times 5. Yeah, I think that's as much as we're going to be able to factor that one there. So we can just leave our answer just like this here. All right, on to number 5. Number 5, we're going to start looking at some synthetic division. All right, so the first thing that you want to do is you want to take your divisor, or the number that's doing your dividing right here, and we want to set that equal to 0. So I have x minus 2 is equal to 0. Add 2 on both sides. So I get x is equal to 2. Once we have that number, I'm going to put that on the outside of my synthetic division hut. There's not really a name for it. Okay, next we want to look at all of our leading coefficients. Okay, always make sure that all of your x degrees are represented. So we have to check x to the third, x to the second, x to the first, and then our constant. So we're fine. We have all of them. We need them all in order. All right, so now I can just write down these leading coefficients. So there's a secret 1 in front of that x to the third power. Then watch out, negative 2 in front of our x squared. Then we have positive 2. And finally, negative 5. Okay, your first number we just bring straight down. So just bring that one straight down. Next, we do 2 times 1, and we write our answer here. All right, so 2 times 1 is 2. All right, go ahead and add negative 2 and 2, we get 0. Now I want to do 2 times 0 and write my answer here. 2 times 0 is 0. Go ahead and add those two together. 2 plus 0 is, well, let's take green, 2. And last but not least, 2 times 2, and write your answer here. We get 4. Negative 5 plus 4 is negative 1, and this I always draw in a box because that is our remainder. So in this one, we actually do have a remainder. So let's finish writing this. Okay, you always go one less degree. So instead of x to the third power, now we have 1x to the second power plus 0x plus 2. Okay, do we have to write that 0x? No, not really. So we could just write plus 2. Minus whatever your remainder is. See how it's negative? That's why I did minus over whatever your divisor is. So see our divisor here is x minus 2. So I'm just going to write x minus 2. And this would be our solution here. Okay, let's try another one of those. Okay, number 6, x plus 5, set that equal to 0. So we get x is equal to negative 5. Write that on the outside of our synthetic division hut. Check to see that all of your degrees are represented. So we have x to the fourth, x to the third. Uh-oh, we're missing x to the second right here. All right, missing x to the second. So we have to say, well, this is really 0x to the second minus 12x minus 14. Write down our leading coefficients, 3, negative 13. Don't forget that's 0, negative 12, negative 14. First term just comes straight down. Now we multiply. Negative 5 times 3 is negative 15. Add them together. We have negative 28. Multiply again. So we have 28 times 5. Should give us a positive 140. Add again. 140 times 5. I believe this one should give us negative 700. So add them up. It's negative 712 times negative 5. So it's going to be positive. So 712 times 5, I believe, gives you 3,560. So then subtract that 14. I got 3,546. Whew. All right, so this one we would have 3x to the third minus 28x squared plus 140x minus 712 plus my remainder 3,546 over our divisor x plus 5. All right.